We'll start by looking at the adsorbing surface, the hydrospheric oxide. And then we'll look at the actual reaction between the arsenate anion and the hydrospheric oxide surface. Then we'll move to the software and look to see how it's built into the software database and then modeled in OLI Studio. Following that, we should have time for some questions. So let's start with a cross-section of a surface. Here I've got on the left-hand side the hydrospheric oxide or a ferric oxide solid phase. And on the right-hand side, I've got the bulk water. So here's a calculation showing the pH on the x-axis and the relative amount or fraction of total of the various species of the hydrospheric oxide surface. On the left side, I have a low pH, and I've got the positively charged hydrogen adsorb HFO on the surface. On the right-hand side, where I deprotonate that surface, I've got the negatively charged oxide hydrospheric oxide species. And in the middle, I've got my base species, my hydrospheric oxide or my hydroxyl group attached to the hydrospheric oxide surface. Now, as you can probably infer from the plot, there is a point in here where the concentration of the positively charged surface and the concentration of the negatively charged surfaces are the same. And at that point right there, which is at about 8.1 or 8.2, there's a net zero charge on that surface. And that's actually given a name. That's called the pH of point of zero charge of the HFO. Now we're into OLI Studio. How do we access that database?